talk about polynomials. In particular, how to graph polynomials. All the graphs that we're going to draw are going to look similar to this. Just that. Those are the only things we do. Sometimes the lows might be lower. Sometimes the highs might be lower or higher. We're just going to graph things like this. Just things like this. If you draw things other than what I just drew, you're going to be wrong. So it's good. We kind of know what the graphs look like. So suppose you were asked to graph y is equal to x minus 2 times x plus 3 times x plus 1. The first thing you want to do is find the zeros. What are the zeros? Even if you have a 7 in front. Well, the first factor, 7, is never 0. Regardless of what x is, 7 equals 7. If somebody tells you x is negative 7, it's insane to say 7 is now 0. 7 is never 0. 7 equals one number and one number only, x. I meant to say 7. 7 is said to be a constant. It doesn't depend on x. X squared minus 2, that equals 0 when x is 2. X plus 3 is 0 when x is negative 3. And if you need to solve it, x plus 3 is 0, take away 3, you can solve it. X is 0 minus 3 or negative 3. What plus 1 is 0? Well, it's not 1. 1 plus 1 is 2. It's negative 1. So now we have the zeros. Let's get rid of this mess. Now we need to do one more thing. We need to decide what happens when x is large. Large means bigger than the biggest zero. Bigger than 2. If x is bigger than 2, what is y equal? Positive or negative? Well, if you're bigger than 2, 7 is positive. If you're bigger than 2, and you take, if x is bigger than 2, and you take away 2, it's positive. If x is bigger than 2 when you add 3, it's positive. If x is bigger than 2 when you add 1, it's positive. It turns out that when x is large, it's positive. Alright. Now we go and we graph this. When x is 2, we're 0. When x is negative 3, we're 0. When x is negative 1, we're 0. And when x is bigger than 2, we're positive. Say out there. Well, there's your graph. Okay, there's your graph. If it would have turned out that x were negative when it was large, then this would have been my graph. Just a mirror image across the x-axis. Okay, but that's not the graph, so let's get rid of it. The only thing, and it's okay in a pre-cal class, the only thing that may be wrong is that, for example, the high part that I just erased could have been a lot higher. Could have been a lot lower. It could have just gone like that. You'll learn how high and how low to go in calculus. But for now, this is perfect. Let's try another one. Suppose you were asked to graph y is equal to negative 3 times x minus 2 times 3 minus x times 7 minus x. The first thing you should do is find the zeros, if any, for each factor. These are the factors. They are the things being multiplied. -3 is never 0. X minus 2 is 0 when x is 2. 3 take away 3 is 0. So x is 0. 7 minus 7 is 0. So those are the zeros. X equals 2, x equals 3, x equals 7. Now, what happens when x is very large? That is, more than 7. More than the largest zero. Well, -3 when x is more than 7 is negative. It's -3. If you're more than 7 and you take away 2, you're positive. If you have 3 and you take away more than 3, like more than 7. If you have 3 and you take away more than 7, you're going to now be negative. And if you're 7 and you take away more than 7, you will be negative. You will be negative. And if I'm not mistaken, the overall sign is negative. Okay. So, in graphing this, I go to 2, I go to 3, 4, 5, 6, and 7. And when x is bigger than 7, I'm negative. So the graph, let's see here, the graph goes like this. Okay, this can be more of a curve. The graph goes like that. Here's your graph. Okay? Should always label your axes. You find the zeros, and then you can graph it. Try one more, then we'll up the level of difficulty. Suppose you were asked to graph y is equal to -2 times 2x minus 3 times 7 minus 2x times 3 minus x, so 3 plus x. Well, what are the zeros? This times this times this times that is 0. One of them or more of them are zeros. Well, -2 is never 0. 2x take away 3 is 0. Well, if this take away that is 0, then they both equal 3. 2x must equal 3. 3 minus 3 is 0. If I erase this, I would put 3, because 3 minus 3 is 0. 2x is 3, so x is 3 halves. That's one of them. The next one, 7 minus 2x is 0. That must be 7. 7 minus 7 is 0. 2x must be 7. X is 7 over 2. That is 3.5. If 3 plus x is 0, x is going to be, after we take away this 3, x will be -3. So those are our zeros. So let's get rid of the side work, which you should literally do on the side. Okay, we have our zeros. Now what we want to do is see what happens when x is large. X is large. If x is large, that means it's bigger than 3.5. Well, the first factor is negative. -2 is always negative. If you're more than 3.5, well, if you are 3.5, if you are 7 over 2, and you get multiplied by 2. Why am I saying 2? Because it says 2x. You're 7. Well, if this number is bigger than 3.5, we will get more than 7. And if 2x is more than 7, when you take away 3, you'll have something left over. If 2x is more than 7, so this is more than 7. 7 take away more than 7 will make you negative. And if it's 3 and you add more than 7, you'll be positive. The overall answer is positive. And you want to pick a number more than 3.5, like 10, you can do that. When x is 10, negative 2 is negative. When x is 10, you have 2 tens or 20 minus 3. Rather than spending the time figuring out what 20 minus 3 is, just say, yeah, it's positive. Okay, if x is 10, 20. 7 take away more than 7. 7 take away 20 is negative. 3 plus 10 is positive. Overall result is positive. Okay, so now we are in a position to graph this. We cross, so 1, 2, 3, 4, 5. 1, 2, 3, 4. Negative 4, negative 3, etc. 1, 2, 3, 4, 5. We have a 0 at 3 over 2. That's 1.5. We have one at 7 halves. That's 3.5. And we have one at 3. And we know that when x is large, that is bigger than 3, I'm positive. Say right here. So, right here. So the graph comes down, up, and back down. It only crosses the x-axis at negative 3, 3 over 2, and 7 over 2. And when x is very large, it's positive. If it would have been negative when x is large, the graph would have just been the mirror image across the x-axis. It would have been that graph. But it isn't. It's the solid one. Okay. Now, let's up the level of difficulty. What if these factors have powers? They have exponents. Y is equal to x minus 2 squared times x minus 4 cubed times x plus 2 to the 5th power. First thing is to find the zeros. If this times that is 0, then at least one of the things in the boxes are 0. And if you square something and you got 0, you had to be squaring 0. That is, what's in the first box, that is the first factor, is 0, only if x is 2. No number other than 0. Then if I tell you something squared or cubed or to the 11th power is 0, what goes in there is 0. Only 0 to a power is 0. 1 to a power is 1. 2 or different powers are numbers other than 0. Okay. If you cube something and you get 0, you must be cubing 0. So x minus 4 must be 0. That happens at 4. Happens when x is 4. 4 minus 4 is 0. If x plus 2 to the 5th is 0, then x plus 2 must be 0. Which means x is negative 2. Those are the zeros. So nothing really changes yet. At 2 we're 0, at 4 we're 0, and at negative 2 we are 0. And we need to talk about what happens when x is large. Well, when x is large, the first factor is positive because you're squaring it. Large means bigger than 4. If x is bigger than 4, if you have more than $4, whether it be $4.25 or $38 or $10 million, when you take away 4, you'll have something left. It's positive. And when you cube a positive, it stays positive. If x is more than 4 and you add 2, it'll be positive. Multiply that number by that positive number by itself 5 times, you'll get positive. The final answer is positive. That is, when x is more than 4, you're positive. Alright, now here comes the twist. Whenever the power is even, that was associated with the 0 of 2. Whenever the power is even, don't cross the x-axis. Just touch it. If the power is odd, like 3 and 5, you can cross. You can cross at 4, you can cross a negative 2. If the 0, when x is 2 in this case, came from x minus 2 to an even power, you don't cross at 2, you just touch. That is, the graph comes down, it crosses at 4, it just comes up and touches at 2, and then it comes back and it crosses a negative 2. And there's your graph. Just touch the x-axis at 2. Why don't we just practice touching and not touching and crossing and not crossing? Suppose we have a number of zeros. 1, 2, 3, 4, 5 zeros. And we're only supposed to touch at the ones I just put the x at. And when x is big, when x is odd, that is bigger than the highest 0, we're negative. The graph will go like this. We cross, we come back and we cross again at the next 0. So now we need to just touch and then cross and then just touch. Notice I'm only drawing things that look like this. Only drawing things that look like that. Either we touch or we don't touch. Either we just touch or we cross. If we don't cross, if we don't just touch, that means we cross. If I don't cross, if I just touch here and here and here, and I also cross here and here and here, and I'm up here when x is large, I'm positive, well, I come down, but then I just come up and touch, and then I cross, and then I come down and I just touch, and then I cross, and then I just touch, and that's it. Okay, this should be more of a curve here. And there it is. Okay, so let's actually do a real one. I'll give you a function. If the power is even, you don't cross or you just touch it at 0. If the power is odd, you do cross. If there is no power, then the power is understood to be 1 and you cross. Negative 3 times 2 minus x to the third power times 3 plus x to the second power times 1 plus 2x to the fourth power times 3 minus 4x to an even power. We need to find the zeros. We need to know, are there any x values that make what I underline 0? Now there is no x value that will make negative 3 0. But 2 minus x, yes. You should know that should be 2. 2 minus 2 is 0. The x is 2. X is 2. 3 plus x is 0. Negative 3. X is negative 3. If you take away 3, you get positive x is 0 minus 3 or negative 3. 1 plus 2x is 0. I hope you know that that's negative 1. If you don't, take it away and you'll conclude that 2x is negative 1. Divide the left side by 2, you just get x. Divide the right side by 2, get negative a half. That's another 0. Negative 1/2. The other 0 is 3 minus 4x is 0. Well, that should be 3. 3 minus 3 is 0. 4 times x is 3. 4 times what equals 3? 3/4. You don't believe it. 4 times this number is 3. So 3/4 is the other one. Those are our 4 zeros. Let's get rid of the side work because I'm out of space. And let's graph this. We have 0, 1, 2. We have 0 at 2. We have 1 at 3/4. So I did those two. Negative 1, negative 2, negative 3. We have a 0 and negative 3. And we have 1 and negative a half. Those are our 4 zeros. And what happens when x is large? Large means bigger than 2. Well, negative 3 is always negative. If you're bigger than 2, if you have 2 and you take away more than 2, you're negative. And then if you cube it, you're still negative. And I never mean to write negative 1. I just mean to write the sign. The third factor. The third factor isn't going to matter because you're squaring. If you square a negative or a positive, it's positive. Same thing with the next factor. You're raising to an even power. It's going to be even. Okay, the next power is an odd one, so we have to be careful. If you're more than 2, well, 4 times 2 is 8. If you're more than 2, 4 times more than 2 will be more than 8. If you have 3 and you take away more than 8, you're negative. And if you raise it to the 5th power, it's negative. There are an odd number of negative signs being multiplied. That means the answer is negative. That is, I am negative when x is more than 2. Alright, now we need to look at the powers. The even powers are when the powers are 2 and 4. They came from the roots negative 3 and negative a half. And negative 3 and a negative a half, I do not cross. I just touch, which means I come up, I cross at 2, I come down just a touch at a half, and I come down and I cross a negative 3 over 2. Okay, just a minor error. It's the root is negative 1 over 2, and I'm crossing at, I put it down at 3 over 2. Negative a half is right here. And let me not be wrong. And a negative a half I just touched. So what? Okay, now I understand. So I just, let us do this again, please. Let's redraw this. Okay. One, 2, 3, 4, negative 1, negative 2, negative 3, negative 4. I have a 0 at 2. I have a 0 at negative 3. I have 1 at negative a half. And I have 1 at 3/4. I got the numbers along here. Okay, now the powers are even for the negative 3 root as well as the negative 1/2. So I only touch there. And when x is very large, I'm negative. So the graph comes up, it comes down, and then it just comes up and touches a -1/2. And then it comes up and just touches a -3. If you notice, my graph only had pieces that look like this. Of course, some could have been higher and lower. That is, I can go high and then hang out here for a while. I can go low and hang out here. But nonetheless, I'm only really drawing this maneuver. Sometimes I draw it high, sometimes I draw it low. In the end, there is our graph. There's our graph. Now what I'm going to do is I'm going to give you 4 graphs and 4 functions, and we're going to try to match them up. 4 graphs and 4 functions, not necessarily in any order, and we need to match them up. For example, if the first graph looks like this, and I tell you this information, that's the first graph. The second graph looks like this. Third graph looks like that. And of course, the fourth graph. Two, 1, and 2. Graph 1, 2, 3, and of course 4. So there are our 4 graphs. We're now going to have 4 functions. Y equals 1/2 x to the 6 minus 2x to the 4. Another one being y equals -x squared times x squared minus 4. The third one being this. And the last one being this. Okay. Let's work from the last one up so I can have more board space. Let's find the zeros on the last one. Well, x can't be factored, but x squared minus 4 can be. Here you can think of x as being squared, and it really is. And here you can think of 2 being squared. 2 squared is 4. So you have x and 2 and x and 2. One gets a minus, one gets a plus. So the zeros are when x is 0, 2, and -2. And for x large, well, if x is large, that means x will be positive. If you have a very, very large number and you take away 2, you're positive. If you have a large number and you add 2, you're positive. So y is positive. So we can kind of graph that. We know we cross at 0 and at 2, -2, excuse me, and +2. 0, 2, and +2. And since all the powers are understood to be odd, namely 1, all the powers are 1. X to the 1, x minus 2 to the 1, times x plus 2 to the 1. Since all the powers are odd, we cross. And when x is more than 2, that is when x is large, you're positive. So the graph goes just like that. And if you think about it, That's exactly graph number 1. That's exactly graph number 1. This is y is equal to x times x squared minus 4. Okay? We need to erase this last equation because I need the board space, please. Okay. Now let's deal with the next equation. I can factor an x out. In fact, I'm going to factor out a negative x because I want the largest term to be positive. Positive x to some power. So I get x to the 4th minus 5x squared plus 4. Now, you need to think of this as a quadratic. Think of what's in the brackets as a quadratic equation in x squared. That is, instead of x followed by a number and x followed by a number, we're going to have x squared. Because what's in the brackets can be realized as x squared squared minus 5x squared to the 1 plus 4. If you let x squared be u, for example, x squared is u squared minus 5, x squared is u, plus 4. This is a quadratic equation. And two numbers that multiply out to 4, but add up to negative 5, multiply out to 4, add up to negative 5, are negative 1 and negative 4. At some point, you should have learned how to factor these type of quadratic equations. Alright, now we can factor some more. For example, x squared minus 1. Well, here, x can be realized as being squared, and 1 squared is 1. It's a difference of squares. X and 1, x and 1. 1 gets a minus, 1 gets a plus. X squared minus 4, we just did that. We just did that. That's x plus 2 and x minus 4. We did it in the last problem. Okay. So what are the zeros? Well, x is 0 when x is 0. X minus 1 is 0 when x is 1. X plus 1 is 0 when x is negative 1. X plus 2 is 0 at negative 2. And x minus 4 is 0 at 4. And when x is very, very large, negative is negative. When x is large, x will be positive. When x is large, x minus 1 will be positive. When x is large, x plus 1 is positive. X plus 2 is positive. X minus 4 will be positive. The answer is going to be negative. So when x is large, I'm negative. And all the powers are understood to be 1. So I cross all my zeros. So let me just move 4 over because this just isn't working well. Okay, here's my 0 at 4. And when I'm more than 4, I'm negative. So I come up, I cross, I cross, I cross, I cross, I cross. If I'm not mistaken, that sure looks like graph number 4. It sure looks like the graph above here. This is y is equal to negative x to the 5th plus 5x cubed minus 4x. Okay, let's do the third one from the bottom. Which somehow I accidentally erased. Okay. That one was y is equal to negative x squared times times x squared minus 4. Oh, not clear what happened, but somehow I erased it from my board, but not from the computer. All right. Y is equal to negative x squared times x squared minus 4. Well, negative x squared or x squared cannot be factored, but x squared minus 4 can. And we've done this enough this afternoon. X minus 2 times x plus 2. So the zeros are at 0. 0 squared is 0. 0 minus 2, 2 minus 2 is 0. And negative 2 plus 2 are 0. Those are the zeros. 0, 2, and negative 2. Now what happens when x is large? Well, if you square a very, very large number, you get positive. But there is a minus in front. And if you have a very large number and you take away 2, you're positive. If you have a large number and you add 2, you're positive. Positive. The overall answer is negative. Okay. So let's try to draw it right here, please. Excuse me. Here's negative 2, here's 0, and here's positive 2. And when x is very, very large, that is bigger than 2, we're going to be negative. Now, with respect to negative 2, the power was 1, so I crossed. With respect to 2, the power was understood to be 1, an odd number, so I crossed. But with respect to 0, the power is even. I don't cross at 0. I just touch. Okay, so I come up, I cross at 2, I just touch at 0 and come back up, and then I cross at negative 2. That graph looks exactly like graph number 2. Y is equal to negative x squared times x squared minus 4. Of course, by process of elimination, you can say that graph number 3 is 1/2 x to the 6th minus 2x to the 4th. But let's work it out. Now, if you're running out of time, if you're short on time, you immediately say that it's graph number 3. But let's just make sure we didn't make a mistake somewhere along the line. I hate fractions by the highest power. So I'll factor out the half, and I'll even factor out x to the 4th. Well, I have the half, and I need right here, and I need x to the 6th, but I only have x to the 4th. I need x squared more. Now, you should know that a half times 4 gives you 2. And I already have the x to the 4th. 1/2 x to the 4th times what? Call it y. Is equal to 2x to the 4th. Well, divide by half x to the 4th. Just get y. Divide by half x to the 4th. The x to the 4th cancels. So now you have 2 divided by half. If you work that out, it's 4. And that's just what I put, just 4. Okay, let's get rid of the side work. So we have 1/2 x to the 4th. And we should be experts now on factoring x squared plus x squared minus 4. Well, the zeros are the x values that make each of those underlying factors 0. The first factor, half, is never 0. The second one is 0 when x is 0. The third one is 0 when x is 2. And the last one when x is negative 2. And where there are no powers, understood to be 1. But with respect to the 0, the power was even, so we will not cross at 0. And basically, we cross at negative 2 and at 2, and we just touch at 0. And when x is very, very large, you can use this equation here. When x is very, very, very large, a half is positive. Raise a large number to the fourth power is positive. If x is positive when you square it, if x is very positive when you square it, it's very, very large. And then you just take away 4. So this factor will be positive. Multiply positives, you get positive. So you're positive. You come down, you cross at 0. I meant to say 2. You just touch at 0 because the power at 0 was 4. And then you just cross a negative 2. And that's exactly graph number 3. Okay. So given graphs and functions, you can pair them up. Okay, that completes this section. Good luck with it, please.